Hello, my name is Miriam Sanchez, and today I will be presenting what unit testing is in software engineering. In this presentation, we will explore what unit testing is, its importance, some key practices, and real-world examples. So let's start by understanding the basics of unit testing and why it has become a cornerstone of modern software engineering. In order to understand what unit testing is, we have to begin with a simple definition. So unit testing is a software testing method where a system's individual components or units are tested in isolation to validate their expected behavior. The primary goal is to catch errors early by testing individual pieces of functionality in isolation. This means testing a single function, method, or class without relying on the rest of the system. So an analogy you can use is think of it like testing each brick in a building to ensure it's strong before assembling the structure. Unit tests are designed to be small, fast, and focused. They should execute quickly, making them easy to run during development. Now, let's take a dive into why it is important and how it fits the bigger picture. So, why is unit testing important? Well, one of the biggest advantages of unit testing is catching bugs early. Fixing issues during the development phase is far less costly and time-consuming than finding them later. Writing unit tests encourages programmers to think critically about their code. This leads to cleaner designs because it's easier to test small, self-contained pieces of functionality. When you modify a code, you can immediately know whether the changes broke something. This confidence is essential for long-term projects where frequent updates are needed. Debugging is faster because it isolates problems from specific unit. Automated unit tests ensure that the code base is stable and ready for frequent releases. And lastly, unit tests also double as documentation. They showcase how a piece of code is intended to work, which makes it easier for new programmers to understand. Now, let's take a look at its key components and how it fits into the development process. So, unit testing focuses on the smallest parts of a program to ensure they work as intended in isolation. Each unit test is independent. This ensures that failures are easy to trace back to a specific issue. Speed is a critical factor since unit tests are designed to be fast. This frequent feedback after every code change helps catch bugs early. By automating test execution, programmers save time. They avoid manual errors and maintain consistency. The scope of unit tests is very narrow. They only target like really like small isolated parts of the system. For example, in an object-oriented program, a unit test might focus on a single method of a class, ensuring it behaves correctly under various conditions. It is written by developers, typically by the same developers who write the production code. So now that we covered key components of unit testing, let's explore the benefits of unit testing. So, as noted in the previous slides, unit testing brings numerous advantages, not just for individual programmers, but for the entire software development process. So, some of the benefits of unit testing include early bug detection, code quality and reliability. It facilitates refactoring, a faster development cycle, documentation of behavior, and support continuous integration. So, while the benefits of unit testing are very clear, there are also limitations and challenges to address. So, what are the limitations and challenges? Incomplete coverage. Unit tests cannot test all possible execution paths or integration issues. Setup complexity. It requires realistic initial conditions, which can be challenging. Dependency management. Mocking external systems can introduce inaccuracies if it is not modeled correctly. Lastly, discipline and maintenance. It requires strict adherence to processes and frequent updates as code evolves. So it is important to note that unit testing is just simply one layer of a comprehensive testing. Strategy, integration, system, and user acceptance testing are also essential to make sure a well-rounded approach to software quality. So let's explore the different styles and approaches to unit testing. So when writing unit tests, there are two main approaches: sociable and solitary testing. So social unit testing, it tests the unit with real collaborators. It focuses on interaction and integration within the system. It assumes other components are functioning correctly. Now, in solitary unit testing, it uses test doubles to replace collaborators. It isolates the unit under test, and it allows testing in controlled environments. Now, the comparison between the two. In a sociable unit testing, the pros are it simulates real-world scenarios. However, the cons are it's harder to identify the source of these failures. And in a solitary unit testing, the pros are it's easier to pinpoint issues, and then the cons are it may not capture real-world interactions. An example could be testing an order system. So sociable testing might use the actual payment gateway. Meanwhile, solitary testing would mock the payment gateway to make sure the order system processes payments correctly. In the next slide, I'm going to be talking about the test doubles. So in solitary unit testing, we use test doubles. Test doubles are objects that substitute real dependencies during testing. They stimulate the behavior of actual components. There are various types of test doubles in unit testing. The types of test doubles are dummy, which is just a placeholder used to fill in a parameter list but isn't actively used in the test. Fake. It takes shortcuts, like for example, rather than using a full database, we may use an in-memory database. Stub provides canned responses. Spy records method calls and parameters. It's useful when needed to verify how a method was called. And lastly, mock. Mock is an advanced type. It's pre-programmed with expectations about which methods will be called. So imagine you're testing a feature that sends emails. So rather than sending real emails, we'd use a mock email service to confirm that feature, calls the service correctly with the right parameters. Now let's see how these test doubles combine into the overall testing workflow and their role in test-driven development, otherwise known as TDD. So the idea of starting with a test before any code is written flips the usual process of code first and then test later. In test-driven development, or TDD, it is a software development technique where tests guide the implementation process. So the steps would be you write a test, and then you implement the code to pass the test, and you refactor. Some core steps in TDD are as follow. Red, which is like a write a failing test for new functionality. Green, write code to pass the test. And refactor, improve the code while ensuring the test still pass. So the benefits of TDD are it promotes clean, modular, and testable code, and it catches bugs early, helping to reduce costs. Something to keep in mind is if you happen to skip the refactor steps, it'll lead to a messy code. Tests can become less effective if it is not maintained properly. So here we have an example code using JUnit. So JUnit is one of the most popular Java testing frameworks. So in this example, we have a class to test. The class is called Adder, and a separate test suite, which is the Adder unit test. So 3 tests were conducted. The first one is a 4.0 input test. It verifies the method add 0, and it returns 0. For the positive numbers test, it checks the addition of 2 positive integers. And lastly, for negative numbers test, it confirms the correct summation for negative integers. So as we see in all 3 tests, there's an assert equals. So assert equals asserts that two objects are equal. If they are not, an assertion error without a message is thrown. If expected and actual are null, they are considered equal. Assertions are simple and they provide clarity of writing tests. So, mock objects in unit testing. What are mock objects? Mock objects simulate the behavior of real objects for testing purposes. We use mock tests to replace complex or external dependencies to test in isolation and control responses, and to speed up testing by avoiding time-consuming setups. So, a scenario in which we can use a mock object in unit testing would be testing an alarm clock with a mock called time service that simulates the current time. This would eliminate the need to wait for real-time conditions. So mocks are related to solitary unit testing. They ensure test independencies and speed. While mocks are powerful, overusing them can create tightly coupled tests, which will make it hard to maintain during refactoring. Continuous integration and unit testing. So, continuous integration, otherwise known as CI, and continuous deployment/delivery, otherwise known as CD, are practices that aim to integrate and deliver code changes quickly and efficiently. So, what are the roles in CI and CD pipelines? They frequent automated test runs to ensure code changes are safe, and they support rapid deployment cycles. So, for example, a CI tool like GitHub Actions triggers test suites after every commit. If the test fails, the programmer will know exactly what went wrong before merging to the main branch. So, some of the best practices are it uses fast unit tests for immediate feedback, separates a unit test from integration and functional tests, and maintains a clean and independent test suite. So to finalize, automated test supports both developer efficiency and product reliability. So to summarize what's been covered about unit testing validates that small pieces of software work as intended, forming the foundation for reliable and maintainable systems. Effective unit testing relies on clear, concise, and independent tests. While achieving 100% coverage is often the main goal or practical, meaningful coverage that targets critical and error-prone areas is far more valuable. The benefits are clear, as stated. Unit tests help catch bugs early. They allow programmers to refactor and update code confidently. Frequent releases become feasible, and overall quality of the codebase improves. Unit testing has its challenges. Writing tests takes time, and maintaining them as the code evolves is equally important. However, we have to keep in mind that over-reliance on mocking can make tests brittle. So, while unit testing may require upfront effort, the long-term effort payoff is higher quality software that's easier to maintain and less prone to bugs.